So in this video, we'll talk about the last 4 multiple choice questions from SAT practice test number 8, section 4. So these are calculator questions. And if you notice what's happened as we've made our way through these problems, the questions do tend to get a little bit trickier toward the end of each section. And I think we're probably into some of the trickier ones that you would have seen within this practice test. So in problem number 27 here, they're talking about the xy plane and the point P comma R lying on the line with equation y equals x plus b, where b is a constant. They give us another set of coordinates also involving the variables p and r. And this ordered pair lies on a different line, y equals 2x plus b. So we see that within the equations both contain y and x and both contain b. What we want to do is we want to determine the value of r divided by p. So what I thought to do here was, well, I know that this point, p comma r, is on this line. So if I simply replace the y in that equation with r and replace the x in that equation with p, that gives me the top equation that you see here. And I'm going to go with the exact same strategy for this ordered pair and that line, right? If a point is on a line, when you plug the coordinates of that point into the equation of the line, it gives you a true statement. It satisfies the equation of the line. So I put 5r in place of this y, so you see that here. And then if I put 2p in place of this x, 2 times 2p is going to give me 4p. And what I noticed, you see that I'm already kind of within a little bit of a sequence of elimination here. I noticed that I have a plus b and a plus b at the end of both of those equations. I noticed my p's were lined up. I noticed my equal signs were lined up. My r's were lined up. So I went ahead and said, well, if I'm trying to determine what r divided by p is, I'm going to eliminate b from this relationship. I'm going to subtract this bottom equation from the top one. And r minus 5r gives me negative 4r. P minus 3p gives me negative 3p. And then b minus b is 0b. b is now gone. Now, I want to determine what r divided by p is, right? We want to know what the value of that fraction is. So if I divide both sides of this equation here by negative 4, that'll remove the negative 4 as the coefficient of that r. And if I divide both sides by p, so that these p's cancel, and after canceling these 4's, you see that we're negative 4's rather, we're left with r divided by p on the left. That's exactly what we were trying to find the value of. And if I do negative 3 divided by negative 4, that gives me 3/4. Negative divided by negative is a positive result. And there you go. It's definitely kind of weird. Sometimes you're just going to have to kind of think outside the box, try anything you can. In this case, plugging those coordinates in and hopefully recognizing, hey, elimination seems like it might be useful to me here, is what worked for me. Might be another way to do this one, but there will be some questions that are kind of tricky. I would definitely rate this one as a 9 or a 10 on the difficulty scale, especially in a time test. Number 22 here, I'll make this a little bit smaller. Got 22 students in a health class. They're doing an experiment. They record their pulse in beats per minute before and after completing a light exercise routine. The dot plots below display the results. So we've got beats per minute before exercise. So what we see here is we see, a big stack at 72 beats per minute, and then, a handful more just right above and below that middle set of data points. The data is really condensed toward the center part of that dot plot. We don't really have anything removed too far from those 4 highlighted columns. We've got, 5 here, maybe 8 more there. We've got, 18 data points highlighted here and only 4 other data points out on the outskirts of the graph. If you look at the second dot plot, after exercise, we see a lot more variability. We see, the data is still spread pretty evenly, right? There's a pretty equal distribution of values below the middle and above the middle, but we see that there is a lot more variability within the data. They're saying that S1 and R1 are going to be the standard deviation and range of the data before exercise. So S1 is the standard deviation of this data set, R1 is the range of this data set, and S2 and R2 are the standard deviation and range of the second data set. We're asked to decide which of the following has to be true. So it's just a comparison between the standard deviations and between the ranges. Standard deviations, the calculator's in play. If you've done any statistics with the calculator, you might know how to get a list in there and do some calculations to determine the standard deviation. I don't think that we have the time to do that here. So I'm going to go and look at the range first. The range is easy to determine. It's just high value minus low value. We get 32 for the range of that first data set. And if you do the same calculation, high value minus low value for the second data set, you get 32. And that actually is quite useful because that allows us to eliminate option B. Range 1 is not less than range 2. It also allows us to eliminate option C. Range 1 is not above range 2. So now it all has to do with the standard deviations. Will the standard deviations of these data sets be the same, or will they be different? If we think about this stack of data points that we highlighted a few minutes ago, those data points are not going to differ from the mean of the first data set at all. A lot of the data points of the first data set are either already at the mean or not differing from it by very much. For the second data set, if we have the mean somewhere toward the center here, we see that we've got the individual data points, not a lot are at the mean of the second data set. We've got them spread much further above and below the mean with data set 2 than data set 1. What that tells me is that the standard deviation of data set 1 is going to be significantly beneath the standard deviation of data set 2. The standard deviations are definitely not equal to each other. We've got much more variability in the second data set than the first data set. The data points differ from the mean by more on average with data set 2 than data set 1, and that's why the standard deviation of data set 1 is smaller than what we see for data set 2. Since it's smaller, it's definitely not equal, and option D is going to be our choice here. Number 29 tells us that we've got a photocopy machine, and we've got 5,000 sheets of paper in that machine initially. The machine starts a large job and copies at a constant rate. That is significant because if something changes at a constant rate, it can be modeled with the equation of a line. A line has a constant rate. The constant rate of change of a line is the slope of the line. It tells us after 20 minutes, the machines use 30% of the paper. Which of the following equations models the number of sheets of paper P remaining in the machine M minutes after starting printing? So what I thought here is let's figure out what the slope is, because I see two of these equations aren't even linear equations. That one's not going to graph a line. That one's not going to graph a line. To graph a line, you need a y equals mx plus b equation. I guess in this case, we got a different variable m actually taking on the role of x, and the variable p taking on the role of y. But because it's a constant rate of change, we're going to be going with the equation of a line. These exponential situations would not depict a constant rate of change. So it tells us that after 20 minutes, it's used 30% of the paper. So what's 30% of 5,000? Well, 1,500 sheets. So how many sheets of paper are left after 20 minutes? Well, 5,000 minus 1,500 is 3,500. Can I find the slope of the line that connects the data point 0, 5,000, the initial amount of paper in that machine, and the one that we just determined after 20 minutes, we've got 3,500 sheets of paper left? Yep. Slope calculation, change in y values divided by the corresponding change in x values gives you a slope of -5. The second option has a slope of 75, and it is -75, right? Minus 75m. So we are looking at the coefficient of the variable in choice B, the slope of the equation in choice B being -75. It's 20 in choice A, which is why we can rule out choice A and side with option B. And then the last question in the multiple choice section is this one. This is actually a super easy question. They're just asking you to do something kind of weird. There's a little chain of calculations that need to be done here. They give you a graph of F, right? So here's a graph of f on the left and a table for g. So we've got the graph of f and we've got the table for g. The maximum value of f is k. Maximum value on a graph is the highest y value on the graph. The maximum value of f is k. Well, the maximum value of f is the highest y value on the graph, the highest function value on the graph, which is 3. So k is really 3. What is the value of g of 3? Well, g of 3, straight out of the table, look in that right-hand column, 6. We'll talk about the grid-in questions in a separate video or sequence of videos.